Today we're going to talk about a method for finding prime numbers. And it is called the Sieve of Eratosthenes. And Eratosthenes is an ancient Greek mathematician and scientist, and he discovered a way to find all of the prime numbers on a hundredths chart. And he used an ancient algorithm, which is nothing more than a way to solve math or to solve any problems. It's a step-by-step solution. We call it a sieve because it's kind of like a net for sifting out numbers, and it sifts out the prime numbers. A sieve is nothing more than like a colander in your kitchen where you would put water and pasta into the colander, and the pasta stays in the top and the water goes through the bottom. Think of a sieve like that. It's like a net or a colander where all of your composite numbers stay in the top in the basket and all of your prime numbers filter out through the bottom. We're going to use this hundredths chart to find all of our prime numbers between 1 and 100, and we're going to use this method here. So this is his algorithm, a step-by-step method. First thing we're going to do is cross out any number that is not prime, okay? So, and then we're going to circle the prime numbers. So our first step is to cross out 1 because 1 is not greater than 1. So first thing we want to do, cross off 1. 1 is not a prime number. Second step we're going to do is circle 2. 2 is the only even prime number. So I'm going to circle 2. Nothing can go into 2 except for 2 and itself. Now, because of that, I know that all even numbers except for 2 are composite. So I'm going to cross off all of my multiples of 2's. And I do that by skip counting by 2's. So 2 is prime, but then I skip count. 4, 6, 8, 10, 12, 14, 16, 18, so on and so forth, crossing off all of my multiples of 2. I just go straight down all the way through my hundredths chart, and already I am decreasing all of my choices by half. So just by crossing off all of my multiples of 2. I now have only odd numbers left. All right, next step I'm going to do is circle my 3 because 3 is prime, but now I'm going to cross off all of my multiples of 3. So I can skip count by 3. So 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And notice I'm crossing off some of these same numbers that I crossed off before with my 2's. One, two, three, 1, 2, 3, 1, 2, 3. Okay. So now I'm left with quite a few fewer numbers. All right, next I go to my next prime, which I know is 5. Circle my 5. Then I cross off all of my multiples of 5. So skip counting by 5's or counting off 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And going so on and so forth. I know all of my multiples of 5 are going to end in either 5 or 0. So I can just go straight on through my hundredths chart, crossing off anything that has a 5 or a 0 in the ones place. and I am eliminating quite a few more numbers. All right, next, 7 is my next prime number. However, all of the multiples of 7 are not prime. So I need to go through and cross off all of my multiples of 7. So I know 7, 14, count off 7 more, 6, 21, 7 more, 28, 7 more, okay. And now I need to circle all of the remaining numbers because all of the numbers that are left are my prime numbers. So going carefully through my hundreds chart, I will now have all of my prime numbers. Oops, got 19. Between 1 and 100. Using this process is a good way when you're taking a test so that you know all of the prime numbers. Because I can tell you, so many times people see the number 51 and they think that it's prime. But 51 is a multiple of 3. 3 times 17 is 51. Next thing I'm going to do, just to make sure that these numbers stand out a little bit more, I'm just going to go through and highlight them so that they are easy to see for you on the video. And there's pretty much 2 methods to determining all of your primes. You can do the Sieve of Eratosthenes, or you can memorize them. If you were to memorize them, you would be memorizing 1, 2, 3, 25. 25 primes between 1 and 100. So a prime number, we know, just to review, is a number that is greater than 1, that has exactly 2 factors, and those 2 factors are 1 and itself. And a composite number is a number having more than 2 factors. Next, we're going to do some practice. So what I would like you to do, once I finish reading the problem, I want you to pause the video. I want you to determine what your answer is, and then turn the video back on, play the video, and check your work against mine. So the first one says, circle the composite number. All right, so go ahead and pause your video. I want you to determine your answer. Now, looking at my choices, I have 3. Using the Sieve of Eratosthenes, I have already found all of my prime and composite numbers. So I know I'm looking for composite. Composite means that it's a number that has more than 2 factors. So using my sieve, 3 is prime, 4 is composite, but let's check the others. 5 is prime, and 7 is prime. My answer for a composite number would be 4. All right, your next problem I'd like you to try is choose the smallest prime number. Pause your video, determine what you believe is the smallest prime, and then check back in. Using my sieve, I can see 1 is neither prime nor composite, and that is crossed off. 2 is a small, it is my first prime number. Let's just check. 4 is composite, 5 is larger than 2, so my answer here is 2. And finally, circle all of the prime numbers in this example. pause your video. Now, I can tell you from experience of teaching prime and composite numbers for many years, students get questions like this wrong all the time. If you take the time to complete your sieve, following the algorithm, going through these 6 steps, you will never miss a problem. Well, I shouldn't say never. You're less likely to miss a problem like this. It says circle all of the prime numbers. So let's go through and look. 74. Well, I automatically know that's not prime because it ends in 2, which is even. So that means it's a multiple of 2, and we crossed all of those off. But let's just check. 74 is crossed off. That is not prime. How about 96? Same thing. It ends in a 6. I know it's divisible by 2, but I want to check my sieve. 96 is not prime. Next, 21. I know my math facts, and 3 times 7 is 21. Let's check on my sieve, and 21 is crossed off. How about 79? Let's look at my sieve. Yes, 79 is circled and highlighted. It is my prime number.